Welcome back to the course Engineering Chemistry. Myself Dr. Harika, Assistant Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. In previous class, we have discussed about the mechanism of corrosion, dry corrosion. In today's class, we are going to discuss about the wet corrosion. Let us see the overview of the wet corrosion. In the wet corrosion, we are going to learn about the evolution of hydrogen and absorption of oxygen. How the corrosion takes place in the presence of moisture, which is also called as electrochemical corrosion, in which electrochemical cell was developed, so it acts as electrochemical corrosion. These are of two types, evolution of hydrogen and absorption of oxygen. And the next topic is differences between dry and wet corrosion. Let us move to the wet or electrochemical corrosion. Electrochemical corrosion. This type of corrosion occurs where a conducting liquid is in contact with a metal. What are the conducting liquids? The liquids which are having ions, which carries the current. Example, either diluted sulfuric acid, diluted HCl, or aqueous salt solution which can conduct electricity by the mobility of electrons. This type of corrosion occurs where a conducting liquid is in contact with the metal. So, the metal, let us take an example of an iron. When an iron is dipped in the diluted sulfuric acid solution or when it is dipped in the aqueous salt solution, there is a chance for the corrosion. This corrosion occurs due to the existence of separated anodic and cathodic parts. In dry corrosion, we have not seen the anodic and cathodic parts. Here, we are going to see about the anodic part and cathodic part. When there is an anodic part and cathodic part, it is also called as development of the electrochemical cell. So, corrosion is because of development of the electrochemical cell, the separation of the anode and cathodic parts in the same metal, between which current flows through the conducting solution. When the iron rod is dipped in the sulfuric acid solution, so there is a chance for the anodic and cathodic parts. Therefore, electrons move from anode to cathode through the conducting solution. At anodic area, always oxidation reaction occurs. At anodic area, always oxidation means liberation of electrons takes place, thereby destroying the anodic metal either by dissolution or formation of compounds. See, if a metal loses its electrons, therefore, metal is converted into metal ion. Therefore, dissolution of the metal has been taken place by the oxidation. Therefore, the place at which, the part of a metal at which oxidation has been taken place, that is called anodic part. Dissolution of the formation of compounds. Metal either by dissolution or formation of compounds. What are the compounds are formed is nothing but rust in case of iron. Hence, corrosion always occurs at the anodic parts. Because where there is an oxidation, there is a loss of electrons, dissolution of metals takes place. Therefore, at that anodic part only corrosion has been taken place. Mechanism. Electrochemical corrosion involves, just a minute. Electrochemical corrosion involves flow of electrons between anode and cathode. Electrochemical corrosion involves flow of electrons between the anode and cathode. When metal rod is placed in a corrosive environment, either aqueous salt solution or diluted sulfuric acid solution or any acid solution, therefore it is a corrosive environment. In the corrosive environment, the anodic part and cathodic part was developed. Therefore, electrons move from anode to cathode. Flow of electrons from anode to cathode. The anodic reaction involves dissolution of metals by liberating free electrons. Let us take that any metal, either zinc or iron. So, a metal which is going to be oxidized to give N electrons. The cathodic reaction involves consumes electrons with either evolution of hydrogen or absorption of oxygen. Here, the anodic reaction in the wet corrosion is similar, but based on the cathodic reactions, it is classified, wet corrosion is classified as evolution of hydrogen and absorption of oxygen. So, Based on the cathodic reaction, wet corrosion was classified. Let us move to the evolution of hydrogen. In evolution of hydrogen, the byproducts or the products are hydrogen gas. Hydrogen gas was released. If the hydrogen gas was released, it indicates that corrosion has been taking place on the metal. In what cases that hydrogen gas will be released? Let us see. It occurs in acidic environment. I have told you before that in acidic environment, either diluted sulfuric acid or diluted HCl condition, when a metal rod is dipped into in the acidic medium, therefore evolution of hydrogen has been taken place. It indicates that corrosion has been taken place on the metal at the anodic part. Metal above hydrogen in the electrochemical series. What is meant by EC is nothing but electrochemical series. There is a series, metals are arranged according to their standard reduction potentials. There is a series, electrochemical series, in which the metals are arranged according to the standard reduction potentials. So, it was started with lithium and it was ended with the platinum or gold from negative values to the positive values. In between, the hydrogen is having 0 value. So, even the lithium, sodium, magnesium, zinc, iron, these are the metals above the hydrogen. These are the metals above the hydrogen. The hydrogen is having the value 0. So, metals above the hydrogen in the electrochemical series undergoes dissolution in the acidic solution. A metal below is copper. Copper is a metal which is below the hydrogen atom in the electrochemical series, does not undergo any dissolution in the acidic medium. It was stable. So, the metal above the hydrogen in the electrochemical series gets dissolved in the acidic medium with simultaneous liberation of hydrogen gas. The net reaction is iron Fe, it gets converted to the ferrous Fe plus 2 ions and liberated 2 electrons. Those 2 electrons are moved from the anode to the cathode in the acidic medium itself. Those electrons are gained by the H plus ions. So, those electrons were gained by the H plus ions indicates that hydrogen gas is released. When the electrons as early as possible is released, these H plus ions gain those electrons and gets reduced to the hydrogen gas. So, the iron metal is oxidized and the H plus ions gets reduced to hydrogen gas. This is the case where cathodes have smaller areas and the anodic have larger areas. Let us take an example. This is a pictorial diagram. This is a diagram. Let us take this is a metal. This is a metal which is placed in an acidic solution. This is a small anodic area and the large anodic area. Small anodic area and large anodic area. If you see this anodic area where there is a large anodic area at which iron is going to be oxidized to Fe to Fe plus 2 ions, nothing but ferrous ions, are liberating 2 electrons. You can see this side also. So, iron is converted to ferrous and liberating 2 electrons. The electrons are moving from anode to cathode. The small cathodic area at which H plus ions exist, it gets reduced to hydrogen gas. The release of the hydrogen gas indicates that there is a wet corrosion and the metal is going to be corroded. This is nothing but evolution of hydrogen. Let us move to the next one, absorption of oxygen. In evolution of hydrogen and absorption of oxygen, we can see the common point is anodic reaction and the difference is mainly in the cathodic reaction. It occurs only in the neutral aqueous electrolyte solution. Neutral aqueous electrolyte solution is nothing but you can take an alien electrolyte. Electrolyte solution is nothing but a salt which can dissociate into ions in the solution medium, the aqueous medium, which is a neutral. Nothing but same number of anions and cations. Let us take an example of aqueous NaCl solution. Iron forms oxide film and if it gives some cracks. Let us take an iron metal. When it is in the presence of atmospheric oxygen, it forms an oxide layer. Let us take that this is an oxide layer. If there is any crack, let us take that this is an oxide layer. This is an iron metal which is an oxide layer. This is a place where there is a small crack. Let us see this. The oxide layer was sometimes the oxide layer which is a protective layer in some cases of metals. So, the protective layer was lost here, there is a crack here. What is a crack? The oxide film has been lost there. Iron forms oxide film. Let us take that this is an iron which is forming, this is an oxide film. If there is a crack in the oxide film which is a protective layer, anodic areas are developed. Therefore, where there is a crack, that is the area is called anodic area. So, it is exposed to the corrosive environment, nothing but aqueous electrolyte solution on the surface of the iron. So, the anodic area was developed on the surface of the iron where there is a crack. That is the crack area is called anodic area. At the anodic area, iron going to be oxidized. If you take an iron as an example, iron going to be oxidized and it releases 2 electrons. Those electrons are gained by, this is we have taken in the aqueous electrolyte solution which consists of oxygen and water, aqueous medium. So, H2 bond half O2 gain those electrons gives hydroxide ions. So, the reduction of oxygen into the hydroxide ions by the gaining of electrons moved by anode to cathode. So, the electrons are moving from anode to cathode, therefore, those electrons are gained by the oxygen and gets reduced to hydroxide. Anodic areas are small and cathodic areas are large. The released electrons flows from anode to cathode through the metal. This is the case where where the anodic areas are small and the cathodic areas are large. Always the electrons moves from anode to cathode. See, these are the products ferrous and hydroxide ions which are formed, which gives ferrous hydroxide or ferric hydroxide. These are the byproducts. These are the products. Ferric hydroxide and ferrous hydroxide. Here the oxygen state of iron is +2. Here the oxygen state of iron is +3. +2 means ferrous and +3 means ferric. Ferrous hydroxide and ferric hydroxide. In the presence of excess oxygen, it gives Fe2O3 and 2H2O water molecules, nothing but rust. In the limited amount of oxygen, it will give ferric oxide, which is a black magnetite. Finally, the metal is going to be corroded. Let us see the diagram. This is the iron metal bar. If you see this is the case where the metal is forming an oxide layer in the presence of oxygen, atmospheric oxygen. And this is the place where there is a crack in the oxide film, which acts as an anodic area. This is a small anodic area at which the corrosion starts. Slowly it will expand. Small anodic area caused by the cracks in the oxygen film where the corrosion occurs. So, Fe gives rise to Fe +2 electrons. In the small area itself, iron going to be oxidized. We can see a small holes in that iron metal box or iron plate. So, those electrons are moved from anode to the cathodic areas. So, where the cathodic area, the oxygen and water molecules gets reduced to hydroxide ions. These ferrous ions and hydroxide ions are going to form a rust at the cathodic area. At the large cathodic area, we can notice the reddish brown color rust or yellow color rust at the cathodic area. So, oxidation has been taken place at the anode and the rust is formed at cathode. So, the corrosion product we can see at the cathode, the corrosion takes place at the anode. So, corrosion takes place at the anodic area in both the cases of evolution of hydrogen and absorption of oxygen, but the products are different. Let us move to the differences between the dry and wet corrosion. In the dry corrosion, it occurs in the absence of moisture, but wet corrosion occurs in the presence of conducting medium. It involves direct attack of chemicals on the metal surface, but it involves the formation of electrochemical cells. Electrochemical cells is nothing but development of the anode and cathodic regions. But here there is a direct chemical action. We can see that gold is dissolved in the liquid mercury. Chlorine gas which reacts with silver and tin. Where silver was protected by the chlorine, but tin is not protected, it undergoes corrosion because of the chlorine. So, it involves the direct action of chemicals are going to be react on the metal surface. Here it involves the electrochemical cells, development of the anode and cathodic regions because of the aqueous electrolyte solution and diluted acidic medium. The process is slow here, the process is rapid process here. The process is slow is because of the corrosion is uniform. Here the corrosion depends upon the anodic and cathodic parts. It depends on the size and anode and cathodic parts of the metal. Corrosion products are produced at the site of corrosion, but here the corrosion occurs at anode, but rust is deposited at the cathode. Here the place at which the corrosion and products are same at the same place, but here the corrosion takes place at anode, products at cathode. Overall, in today's class, we have come across the wet corrosion, which is also called as electrochemical corrosion, wet corrosion or electrochemical corrosion. Electrochemical corrosion is nothing but there is an existence of anode and cathode. Wet corrosion is of two types. The first case is evolution of hydrogen. The name itself is depend on the product which was released called hydrogen gas. Evolution of hydrogen has been taken place in the acidic medium. The second case is absorption of oxygen. This is the case at which therefore the oxygen was absorbed. So the corrosion where it taken place, the oxygen was consumed and the rest we can notice. In both the reactions, the anodic reactions are same, but cathodic reactions differ. Same anodic reactions, but differ in cathodic reactions. Here the corrosion takes place at the anode and the products are formed at the cathodic regions. And we have seen that in today's class we have seen the differences between dry and wet corrosion. Dry and wet corrosion. In the next class, we are going to discuss about the types of corrosion, different types of corrosion. Thank you.